Hi everyone, my name is Harry Howard and I'm a postdoctoral research fellow at Macquarie University in Sydney at the Center for Quantum Materials and Applications. Today I'm going to talk about gravitational waves and their detection with high precision optomechanics, specifically a small scale space-borne probe which uses laser-cooled optically levitated nanoparticles for search for a variety of sources associated with high frequency cosmic events. I'm going to share my screen now. The search for coherent field effects generated during cosmological inflation or phase transitions in the early universe requires high sensitivity detection technologies, which are very different from the traditional particle physics detectors. In this context, force sensing with optomechanical levitation is one of the fastest growing next generation enabling technologies around and may provide a new type of astrophysical and cosmological probe. When resonant optical cavity interferometers will achieve the required sensitivity, novel gravitational wave physics data can be collected. We propose the use of a levitated dielectric nanoparticle trapped in a Fabry-Perot cavity as an optomechanical sensor for gravitational waves. The particle is trapped in high vacuum within the standing wave field of an optical cavity cooled through coherent scattering. The gravitational wave of a given amplitude and frequency will modulate the distance between two spatially separated points that is on a plane that is perpendicular to the direction of the propagation of the wave. In the presence of a gravitational wave, the position of the sensor changes due to the interference of the two counter-propagating waves in the optical cavity, causing an oscillatory driving force on the particle. Such a setup can be used for high-precision tests of gravitational physics and detection of gravitational waves at micron distances where feeble interactions require sensitive measurements and excellent decoupling from the environment rather than high energies. The sensor will enable us to study different protocols and experimental techniques to push further the required sensitivity for future development of gravitational wave detectors. The effective optomechanical coupling of the levitated nanoparticle and the cavity promises access to a large parameter space for high precision gravitational wave sensing, not yet explored by classical ground and space based observatories, and interesting for many potential astrophysical sources. Thank you. I'll stop sharing now.